السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. In the name of Allah, the most gracious, the most merciful. إن شاء الله في صوت. لو في صوت حد يكتب لي على البرايفت أو أنا أعمل لكم فرصة إنكم تقدروا تعملوا unmute للصوت اللي عايز يرد بالمايك. Okay, so if there is voice please.
ايوه مستر في صوت.
طيب okay, thank you.
الصوت واضح.
طيب الحمد لله, thank you. Today إن شاء الله رب العالمين we will talk about section 4. This section is very important because it includes very new concepts. Okay, I think they may be the first time to be studied by 10 set students. Okay, so please concentrate, inshallah. I mean, we will try to make it as easy as possible, inshallah. Okay, now, inshallah, we will talk about the color and the polarization. As we know that the white light, and when I say white light, I mean the light that's coming from the sun. Okay, so the white light is the light that's coming from the sun. It's the light that includes all the wavelengths and the frequencies of the electromagnetic spectrum. Okay, this light has can be separated into 6 elementary colors. As we said, this phenomenon is called what? Dispersion, light dispersion. Okay, and it happens inside things like prisms and droplets of water. Okay, and welcome Khalid and Muhammad Khalid. Okay, so we studied that this white light can be analyzed, can be separated into its 6 components. Okay, those are composing what we call the visible light colors. Okay, red, orange, yellow, green, blue, and violet. We studied these colors together. Okay, inshallah, it's clear. Well, these colors are called light colors. Let's call them light colors, and let's differentiate them from the pigments or the paints or the dyes. Okay, so there is 2 kinds of colors. Light colors, the colored light, okay, and light paint, light pigment, okay, it's a colored substance. So we have, for anything to differentiate between these 2 kinds. Well, now inshallah we will talk about the methods of finding single light color. This is a very important point. For example, I want to find a green color, only green color, single green color. How can I do it? I can do this by reflecting objects on a colored surface, or by passing light through transparent colored membrane called filter. Light filter, called what? Called light filter. Well, let's explain this point, the reflecting light of color. We know that we see this paper green. Why? Because when the white light falls on it, it will absorb all the colors except for its color, which is green. It will reflect it. Okay, so the reflected light will be green only. So this is the white color that's coming from the sun, okay? When this is the incident color, it's white. This is the incident light, it's white light. It's a composition of all the elementary lights. Those are composing the white spectrum, okay, or the white light that's coming from the sun, okay? But the reflected light will be what? Will be only the green, and the same will be in case of red object. If the white color falls on a red object, this red object will absorb all the components of the white light and will reflect only its color, which is the red. So this is the first method to find or to get a single light color. The second method is by passing the light which is, I mean the white light, through transparent colored membrane called light filter. For example, here, this is the incident color. This is the white light. It's incident. Okay. This is the transparent membrane. It's green filter. It's green filter. Here, I chose it as green. I can make it blue, yellow, red, as I want. Okay, so this color that's passed is a green color. Okay, it means the membrane will absorb all colors except for its color. It will allow it to pass. I hope it's clear. If there is a question here, guys who joined late, huh? Do you understand well? Who said that? The white color is composed of the 7 colors. Okay. Then we said that how can we extract only color from these 7 colors? Okay. And now we are talking about the light colors, not from not about the colors as pigments or paints. Okay. Is it clear? Well, alhamdulillah. طيب. Now, inshallah, we will talk about this point, light and color. When light shines from the sun, this is a summary, we call it white light, and it includes all the colors in the visible spectrum, okay? Each of these colors, when added together, if we make the opposite, if we add all the single colors or the 6 single colors to each other, what will happen? They will give the white light again. I think it's logic. Okay, so we call this method of mixing light as additive mixing, and we call these colors, or in other words, we call the light color or light primary colors, okay, as additive colors. Be careful, this is light, not paints, not pigments, not paints. Paints are not included in this description, okay? Well, now, welcome Yahya, mashallah. Welcome Yahya. طيب. Now, we will talk about the...
Sorry, Mr. for being late.
Okay, don't worry, don't worry. The colored lights are mixed by adding them together to give white light. Okay, again, Yahya, again, everyone, to understand what we were talking about. We said the white color can be analyzed, can be separated into its components, which are the 6 colors. Each color is called colored light or light color. These colors, when they are mixed together, we call them, they will give the white light again. So this mixing process is called additive mixing or mixing by addition, okay? So, and this is only correct for the light colors, not for the paints, because the light color, the light color or the colored light is different from the colored paint or pigment, okay? Now we are talking about the colored lights. Colored lights are mixing by adding them together to give white light, okay? So by using, how can we mix them? How can we mix them? This is a question. How can we mix them? Number one, by using a lens like this. For example, I'll make the 6 colors fall like this. They will meet each other here and will give me the white spot here. So this is adding, okay? If this, for example, this is red and this is violet, okay? Each one is single ray, okay? By laser, by any way, imagine that. If we can mix them or add them to each other by a lens like this, okay, it will give us what? It will give us the sense of white. And we can make this by combining light that has been passed through red, green, or blue filters. Please concentrate on this or focus on this point, especially these 3 colors: red, G, green, B, blue, especially these colors. We found that when they added together, they will give the white also. They will give the white also. So these 3 colors are experimentally found to be 3 color lights. Those can be mixed together to give the white light also. And I'll explain why. Okay, but before anything, we have to memorize these 3 colors well. RGB. كل سنة وانتم طيبين. رمضان رمضان كريم. These RGB remind us with not Ramadan, but what? Rajab. Okay, Rajab. RGB, red, green, blue. Memorize these colors well, or colored lights well. These 3 colors are called additive primary colors. Why? Because when they are added in varying properties, they can form all the other colors of the spectrum. For example, R and G will give another color of the spectrum. G and B will give another color of the spectrum. So when you make these 3 colors fall on a screen, for example, this will give the 7 colors, in fact, the 7 colors of the spectrum. So they will give the sense of what? The sense of white light. I hope it's clear. If you have any problems with what I'm explaining now, please, you can unmute yourself, or you can write it on the to the chat. Okay, well, let's clear the drawing. So we agreed together. Ragab, R, G, B, these colors are called primary additive colors or additive primary colors. And these are lights, by the way, lights, not pigments in this image in front of you. Well, let's see together. Someone wrote in the chat, Omar Hilal said, I didn't hear at the beginning when you said something about pigments. Could you explain, please? Now, Omar is asking on the chat, okay? This question is sent by Omar. Omar Hilal, listen well. When I talk about the colors, I have to differentiate between two types of colors, okay? Number one, the light colors, those we are explaining now, okay? Number two, the colored paints, the colored pigments, okay? The colored objects, okay? So we differentiate between them. Now we are talking about the light colors. The colored pigments will be explained, inshallah, a few minutes later. Is it clear? I hope it's clear, inshallah. طيب الحمد لله. Okay. Well, so this is a red light. This is a blue light, and this is a green light. Let's look at these the mixing of these three lights. Now these colors, red, green, blue, they are Basil. So we are talking only about sunlight. No, not only about sunlight. We are talking about the colored lights. We can get them from sunlight, from any source. But sunlight gives us what? Sunlight gives us the white light. Okay, and it can be also from other sources. But yani the most popular source and the most common source is the sun. Okay, I hope it's clear, Basil. Okay, well, red, green, blue, welcome. These are called primary. These are called primary. Well, but look at this, cyan. Okay, cyan is the color that's composed when blue and green mixed together. Okay, so this is green, this is blue, so this color is called cyan. So the color of the sky, by the way. Okay, so it's called blue green, blue green. Okay, well, if the red and the blue, red and blue are mixed together, they will give us this color, which is called magenta. So this color is called magenta. Okay, so this is cyan, this is magenta. Okay, and this, when we add red to green, this color will be called is yellow, the known yellow. Nothing new here. Okay, so we have to memorize these pairs. Okay, cyan equals blue plus green. So blue plus green equal cyan. Okay, the magenta is red plus blue, so it equals magenta. Okay, so the cyan is called the complementary to red. Because this is the cyan, okay? It's the complementary to red. What does it mean complementary? When it's added to the red, it will give the sense of white. But I'm not interested in this point now, okay? The magenta is called the complementary to green. Look at this. This is the magenta. It's in front of the green. The green is the remaining color, okay? So, and the yellow is formed when red plus green equals yellow. Well, so Mahmoud said, wrote, Mr. Does the color magenta, cyan, and yellow also form white? It's a very good question, Mahmoud. Look at the screen here. This is the region of what? Of magenta, and this is the region of what? Of yellow. This is the region of what? Of cyan. So when they are mixed together, it's a very good question, Mahmoud. When they are mixed together, they also give the white. Okay. طيب. Excuse me. Let me recall the attendance. Okay, thank you. Well, there is another question by welcome Mahmoud. Omar Hilal said, Mr. Aren't the cyan, magenta, and yellow called secondary colors? Yes, they are called secondary colors, and we will write this. Excellent, Mahmoud. Excellent, Omar. Sorry. So these are called additive, secondary colors. Why are they called secondary? Because they are resulting from what? From mixing of two primary colors. Okay, so they are called additive secondary colors. Okay, well, now inshallah Rabbil Alameen, we will talk about the second type of the colors. Okay, Abdulaziz, in the beginning of the period, because you joined late, okay, in the beginning of the period, we differentiate between two types of colors. Okay, the colored lights, the colored light, the red light, the blue light, the yellow light, and so on. Okay, and the colored pigments, the paint. Okay, like the blue ink, for example, the blue paint, and so on. Okay, so all what we explained was about the colored lights. Now we will talk about the colored paints, the colored dyes. Dyes means pigments, sabghat. Okay, for example, for the clothes and so on. Okay, and pigments or filters. And we said, what's meant by filter? Filter is the transparent membrane. Okay, this transparent membrane, if it has certain color, okay, it's called filter. Okay, so if you have a plastic piece, okay, transparent, and it's, for example, it's red. This is called a filter. Why? Because when the light falls on it, it will absorb all, or because it's a colored object. يعني easily it's a colored object. خلاص عشان بس ما يحصلش interference. Well, these colors are called subtractive colors. Subtractive of subtraction. Why? We will explain now. Look at this figure. Now this is a red object, red pigment, red paint. When the light falls on it, what will happen? It will absorb all its colors or other colors and will reflect only its colors. So for example, this is red paint, red color, red filter, okay? Red object, red dye. Filter will not reflect, filter will pass, okay? So the reflected light from them will be red, okay? In case of green, the same will happen. Well, if we mix these two colors together, what will happen? The first one absorbs all except for red. The second one absorbs all except for the green. So when we mix them, what will happen? The first one will absorb the green, and the second one will absorb the red. So no color will be reflected from this mix. So we will see black color. We will see black color. Okay, is it clear? Is this point clear? Muhammad Khalid said, Mr. What if the absorbed color is white? It will be black, Mahmoud. Okay, which color will, if the absorbed color is white, no reflected color. By the way, I see, Muhammad, I see the reflected color. Okay, so because no reflected color came to me, I see it's black. Okay, Muhammad says also, Mr. What if the absorbed color is, okay, is it clear? No color will reflect, so I'll see it black, Muhammad. Okay, Abdulaziz says, Mr. Can you repeat this part, please? Okay, I repeat it again. Okay, Omar Hilal says, what if the reflected color is black? No color, black means no color reflected. Black is a piece of darkness. Welcome, Muhammad. Okay, Omar, we can describe the black as a piece of darkness. No color reflected means black. Okay, well, look at Abdulaziz. Welcome, Omar. Look at Abdulaziz. The first one reflects what? Red. This is any paint. Okay, the first one reflects red. This red, this is a paint. The second one reflects green. Well, when we mix them, the green that's reflected by the second one will be absorbed by the first one. And the red, which is reflected by the first one, will be absorbed by the second one. Okay, so in fact, no colors will be reflected. So my eyes are waiting for the reflected color. Will my eyes find any color reflected to them? Huh? Abdulaziz, answer me. Will they find? When we mix these together, no, Abdulaziz. Why? Because the color that's reflected from this is the reflected from the second one is green, so it will be absorbed the red, because the red object, the red paint absorbs the green. Okay, and the green will absorb the red color because the green absorbs red. So no reflected current, color, sorry, will reach my eyes. Okay, so I'll see this mix as black. I hope it's clear, Abdulaziz. Is it clear now or not? طيب, alhamdulillah. So color paints, dyes, and pigments, welcome. Because when they are added together, each one takes the color reflected by the others. So all light is absorbed to produce black. So these colors are called what? Subtractive. Why subtractive? Because they take the colors from the white color. Okay, they absorb the color. Okay, so this is called subtractive. Well, the subtractive colors are the subtractive primary colors. We said Ragab. Okay, here we can say Yamak. Yamak. By the way, there was a student called Muhammad Yamak. So you can say Yamak is a famous name, I think, in في لبنان, I think. Okay, isn't it, Mahmoud? Is it famous name or not? طيب يبقى famous name. Okay. محمود man اسمه يمك. Okay, is it famous or not? Don't worry. Is it famous or not? كان عندنا طالب اسمه يمك قبل كده، محمود يمك. والله انا كل ده فاكرك من لبنان يا طيب. Okay, sorry. Well, Palestinian, mashallah, mashallah, mashallah. Okay, so YMC, remember Ragab and Yamak. Ragab and Yamak. RGB, the primary additive colors. YMC are the primary subtractive colors. Y is the yellow. M is the magenta. C is the cyan. Someone Abdulaziz Wagan. طيب الحمد لله. Someone may say, Mr. These are the colors we explained a few minutes ago. Excellent. Okay, so these are, in case of paints, in case of pigments, they are called the primary colors. And when they are added together, they will give the black. So here, this is the cyan, and this is the magenta. This one is the magenta. Okay, this one is the yellow. When we mix the cyan with the yellow, it gives what? Huh? It gives what? Who can tell me from this diagram in front of you? Excellent answer, Muhammad Khalid. Mumtaz. An excellent answer, Mahmoud Ghaid. It will give us green. Okay? And when we add the yellow to the, let's see, the magenta. Excellent. It will give the red. Okay? When we add the cyan to the magenta, it will give what? The blue. Excellent, Muhammad Khalid. Excellent, Mahmoud Ghaid. Okay, well, but when we add them together, they will give us the black. And even if we add, so the green is here is a secondary additive, subtractive yellow. Okay, there's a color, sorry, subtractive color. Well, now, inshallah, we finished. Now we finished the colors, and we will talk about something called the polarization. Okay, we know that the light waves oscillate in all directions, or as they call, and I hate this word by the way, in random directions. Okay, when they shine from the sun or other sources. For example, the color may vibrate in this direction. Let's say this is X direction, okay, sorry, Y direction. The field will be vibrate in this direction, okay. It may vibrate in X direction. It may vibrate between X and Y, okay, like this figure, Look at the pointer here. The color vibrates in all these directions. It vibrates like this, or up and down, left, right, diagonal like this, and so on. So this color is called unpolarized. This color is called unpolarized color. This is the normal color. Unpolarized. This is the nature of the color. It's unpolarized. Unpolarized light. I'm so sorry. Okay. So this is the shape of the waves. They are vibrating, as you see, in many directions, not in single direction. Okay. This direction, diagonal, horizontal, vertical, and so on. So this is called what? It's called the unpolarized color. So we give it this symbol to show these the different probabilities or the different directions of the vibration of the fields of the magnetic. We know that the electromagnetic color light is a mixture of vibrating electric field and magnetic field. Well, now, inshallah, we'll talk about something called the polarization. We will change this color from, or this light, I'm sorry, okay, from this case where the vibrations happens in all, the planes of vibrations are in all directions or in many directions, into light that vibrates. It's a plane of vibration, okay, the plane of vibration is only one direction. The light waves can be polarized, okay? In polarized light, all the light waves oscillate in the same direction as this, but this is called the polarizer, okay? So this is called polarizer. This is polarizer. Okay, so this is unpolarized color, and this is light, and this is polarized light. Well, so the polarization is what? The polarization is the alignment of electromagnetic waves in such way that the vibrations of the electric fields in each of the waves are parallel to each other, like shown in the figure. Okay, the polarization